Hey calculus kids, this is Dr. Callahan for week 17, Monday. I hope you guys had a wonderful weekend. Go ahead and pause the video and answer the following 3 questions. This is actually the last week before your finals, which is in week 18, so that is coming up. And if you do need to have a week 17, 16, 18 guided notes and whatnot, they are outside of B1. So pause the video and answer the following 3 questions. All right, let's go ahead and take a look at your MS team. I'm gonna go ahead and create the assignment for you guys so that way you get the points when you click on it. So here is calculus. And let's go ahead and add the assignment, create. So this is week 17, Monday, and today we are going to talk about linear approximation in the lhopitals rule. And so let me go ahead and just copy that over to MS Team. So week 17, Monday, Calc AB semester 1, linear approximation and lhopitals rule. Okay, that's as far as it will let me go ahead and do that. It's okay. So your instructions here is pretty simple. It's similar to what we did in every single day. And in addition to that, I want to make sure that I go ahead and provide you guys with the guided notes as well. So let me just go ahead and save this over, which it is. And here are your instructions for today. Okay. So make sure you guys view the assignment, watch the video, fill out your guided notes, take a picture of your work and upload it to this assignment. You don't have to do that from Monday through Friday. You don't have to really actually upload anything, mainly because your assignment generally will be on Math Excel and also AP College Board. However, if you would like to, you could take a photo of it and then upload it onto this as well. Today's video will be uploaded by 8:30 on week 17 Monday. As you know, I'm making it right now, so obviously you can't really view it as I'm talking, although you probably could because you're watching it now. So if you have any questions, I do have a Zoom Monday through Friday from 10 to 10:30. It's the same passcode, same meeting ID. If you need a hard copy of your notes, they're located outside of B1. The building closes at 3:30, so make sure you guys get there beforehand, and it's just located right outside, so you can pick up anytime you want between the hours of 7:45 till 8:30 when the building opens and closes. My email is right here on the bottom. We're getting towards the end of the semester, so if you have any questions about your grade, please email me with your concerns. I'm really responsive about getting back to you guys with your emails, usually within 24 hours or maybe even earlier. Your assignment for this is actually due on Monday, which is the 17th by 11:59 p.m. So make sure you guys, actually I shouldn't even say 11:59 p.m. That should be done before then. I'll just put 3:30 p.m. There you go. And other than that, that's basically it. I do, however, have an extra credit assignment for you guys. It doesn't really have anything to do with math, but your math teachers decided, or from Huck High School anyways, decided to go ahead and give you some season greetings. I have a little YouTube video, and if you post a positive comment on how the teacher has affected your life and words of encouragement for all that a teacher has done for you, it's worth 10 points extra credit. It doesn't really have anything to do with math, but it's kind of like our last ditch effort to kind of give you that boost for your grade in case you do need it. But the link is right here, and I'm just gonna go ahead and assign it. So hopefully that will go through. And let's go back to calculus and make sure that it is posted. It's not quite there yet. Oh, here we go. I'm gonna hit reply right here, and I'm gonna go ahead and paste this piece right here. and hit enter. So this is just a season's greeting from all of us from the math department. I know this year has been really, really odd. A lot of these teachers you probably had in previous years, especially if you're not a freshman at Huck High School. And we just want to say hello. And even though we don't have you guys in person, we are still thinking about you guys. And so watch the video, post a positive comment, and it's an easy 10 points extra credit. Now, in addition to that, I want to make sure I post the guided notes for today in case you need to make a copy or print it out for week 17 Monday. And let's go ahead and attach that. It'll be in a form of a PDF, so even if you don't have PowerPoint, that's not an issue. I convert everything to a PDF because I'm thinking most computers probably have Adobe PDF downloaded for it, whereas not every computer has PowerPoint. So we want to make sure that you guys are able to access everything. So week 17, and it doesn't seem like it's converted yet. No, it looks like it did, but it's not there. Let's try one more time. Let's see what's going on here. Oh, here we go. I see it. It's right here. It does not exist. It does exist. Okay, so let's try something else. Let me do File, Save As. Sometimes it's a little bit finicky, and that's okay because copy, paste, and we cancel that. Sorry, it's just being a little bit problematic, but we will get down to this PDF and save. Okay, so while it's doing that, I'll go back to this later because I don't want to waste any more of your time. Let's go ahead and proceed forward with today's stuff. Let me share back to this. Okay, here we go. Okay. So last time when I saw you guys, we went over a review of some of the questions from Unit 3. We went over 2 different examples of optimization and also related rates. Those are obviously more difficult questions for Unit 3 and Unit 2. This is a breakdown for today. So go ahead and take a look at this. We're going to talk about triangle related rates and then also linear approximation and the lhopitals rules. So that is kind of like our big questions for today. So with that said, go ahead and take a look at your notes today. This is the first page that you should have for week 17 Monday. Now, once again, you can pick up a hard copy of this outside of B1, or you can go ahead and take a look at the guided notes that's attached to week 17 Monday's assignment on MS Team. I haven't attached it yet because I'm having a little bit of glitch, but it will be there because you have the PDF available for you every single day for this. So if you want to print it out at home, that's entirely fine. So right now, what I'm going to have you guys do is maybe pause the video, answer the following 10 questions or 11 questions on first and second derivative. If you do need help, there is a link right here, which if you click on it, or if you actually get to it, it is a multiple choice of exactly what you have. So even if you don't have the paper in front of you, you can go ahead and just start working on this part here on Mathopoulos. And then let's say I click on this one, it's incorrect. And on the bottom, it explains to you as to why it is incorrect. So it is a review of part of Unit 3. So go ahead and pause the video. And actually, I'm sorry, you can't see that. Here we go. This is where it goes to once you click on the link and answer the following 11 questions. Okay, so then let's go ahead and move forward with today's stuff. So this is the second page of what you should have, which is going to be on the triangle related rates. And we're going to go over a few of these questions right here. Okay. Now, this was one of the questions from previous day in this class, and I wanted to make sure that we go over a question like this as well, just so that we're holistic and everything that we can possibly go over, you have this available. Okay, so go ahead and read the question so that way you're familiarized with what it's asking you. It's an optimization problem that is asking you to find the first number and also the second number with subtle hints in between. And so as I'm reading this right here, let's go ahead and break this part down. It says the sum of the first number is going to be squared and the second number is 27 and the product is a max. And so the breakdown of this is A, write out your primary equation. And so essentially the primary equation is always going to be what is the equation or what is the question asking? And so the question, what it's asking is that it is asking for the product is going to be a maximum. Okay. So the product is the maximum is P equals X times Y, with X equals the first number and Y equals the second number. B, write down your secondary equation. Now your secondary equation is always going to be the other equation that is going to be helping you to isolate one of the variables for the primary equation. And you're going to be using that and substituting it back into the primary equation so you have just one unknown equation. And that way you can find the derivative of the primary equation, solve for X or Y, or the one independent variable that you don't know. And that will be your critical point. So for B, write out your secondary equation. Your secondary equation is going to be this little hint right here, right in the beginning, which is going to be the sum of the first number squared. First number is X, so X squared. Sum means plus, and the second number, so second number is just Y, is 27. And the second number, it usually always gives you what it's equal to because you cannot solve for one of the unknown variables if you have two unknown variables like X and Y, and you don't have it equal to anything. Like if you look at the primary equation, you don't have actually anything given to you. It's not equal to a product. It's not equal to an actual number. So your secondary equation, you will always have it equal to something, just so you can kind of isolate the variable. I always like to go ahead and have everything in terms of Y. So what I'm going to do is I'm going to solve for Y in terms of X. So Y equals 27 minus X squared. And then what I'm going to do with this is I'm going to take the 27 minus X squared and substitute it back over here into the primary equation. So then my primary equation is going to be X times 27 minus X squared. And let's go ahead and distribute that. So then I have P is equal to 27X minus X to the third power. Then let's go ahead and proceed to finding the first derivative. So it's just going to be a simple power rule. Set it equal to 0, solve for X, which is going to be your critical point, okay? Negative 3X squared equals negative 27. X squared equals 9. X equals a positive and negative 3. All right, so now that I have two numbers, and because it's just a number and it's not like the length of a fence or something, you can actually have a negative 3 for X because with the fencing problems, you can have a negative 3 feet of fencing. But whereas with a number, it is absolutely acceptable to have a negative 3. So you have two critical points. Now, the question here is asking for a max. So if you know it's a max, if you're doing a sine line, you should have a positive slope followed by a negative slope. But unfortunately, I don't know which of the critical points is going to give me a maximum. So what you can do is you can go ahead and do a sine line. So put down negative 3, put down positive 3. One of those will give you a maximum as long as when you test the slope on the left side and the right side, it results with a positive slope on the left side and the negative slope on the right side. So then you can do f prime of negative 4, f prime of 0, f prime of 4, positive 4, and see what's going to happen there. Now, if you decide to do something a little bit different, like with maybe a second derivative, you can do that as well. So let's try a different method. If I were to find f or p double prime of x, which is just going to be the derivative of 27 minus 3x squared, you will get a negative 6x. Okay, and so then if I were to go ahead and plug this in with a positive 3 and plug in the negative 3, remember the rules is that if p double prime of x is greater than 0, then it's actually not a max, it's a min, because remember it's kind of reversed. And then if p double prime of x is less than 0, it's actually a max. So they are reversed. Okay, so this is actually pretty simple to do because negative 6 times 3 is a negative 18. Negative 3 times positive 6 is a positive 18. So where is your max? Well, this is telling me this is the max. And this is telling me that it's a min. So when x is equal to positive 3, that is where my maximum is going to be located. So what that means is that my first number here is going to be a positive 3. Now I got to figure out my second number, which is going to be y, and you know that the product of x times y equals p. And it's also given to you that if you look at the secondary equation, y equals 27 minus x squared. So let's just do 27 minus 3 squared, which is 27 minus 9. So your y is 18. So what are your two numbers? First number is positive 3, second number is 18. And that's how you would answer this question. All right, so then let's go ahead and jump in with your triangular related rates right here. And let's go ahead and get started with the first example for A. Okay, so this is more similar triangle, which is on shadow problems with related rates. So here it's given to you that dy over dt equals ROC of the shadow. So then here's your triangle, and let's go ahead and perhaps draw the diagram so we have a better understanding of this. So here's your small height. This is the big height. Here's your x. Here's your y. Okay. Now, the proportion of this is always going to be small h over big H equals to y over the entire length of this. So it's x plus y. Let's go ahead and take a look at an example so that way we have an idea as what to do with this. So with example 1, it says a man 6 foot tall is walking at a rate of 5 feet per second. So then your dx over dt is equal to negative 5 feet per second towards a lamp post that is 15 feet above the ground. So here is a lamp post, 15 above the ground. The man, which is this person right here, is actually 6 feet. Okay, and then here's your x, here's your y. And it says when he is 10 feet from the base of the light, so 10 feet might be like over here somewhere, okay? When is he 10 feet from the base of the light? Oh, okay, so when? So that's the question they're asking. So then A is, at what rate is the length of the shadow changing? And if you're looking at the length of the shadow, if you look at this right here, the shadow is actually going to be the y part right here. So you're looking at the dy over dt, okay? And that's going to be the first portion of this. So let's go ahead and set this up for A. So with the formula that I provided right here, let's go ahead and have 6 over 15 is equal to y over x plus y. I would suggest that you cross multiply this. So then you're going to distribute the 6. The 6x plus 6y is equal to 15y. And then combine your like terms by moving the 6 over. So you have a 6x on the left side, move the negative 6y over to the right side, and you have a 9y. Now looking at this part right here, the rate of change for this is going to be 6 dx over dt equals 9 dy over dt. And you're given that the dx over dt is right here. So then what I can do with this is I can go ahead and replace that with 6 times -5 equals 9 dy over dt. Our goal here for A is to find the rate of length of the rate of change for the shadow. So you're going to solve for dy over dt. So dy over dt is equal to -30 divided by 9. And that is your answer. And if I reduce that, it reduces down to a -10 over 3 feet per second. Okay, so then my B question here is asking at what rate is the tip of a shadow changing? And that's where you come over here. So this is saying rate of change of the tip of the shadow. And that formula you're going to use is dy over dt plus dx over dt, which makes sense because if your shadow is changing as you get closer over to, 10 feet away from the pole, it is going to be the change of the x plus the change of the y, which makes sense because that will be the rate of change of the tip of the shadow as you're moving closer or further apart from the lamp. So then my equation here is, whoops, let's see. I'm just gonna move it up a little bit. dy over dt plus dx over dt, which is equal to dy over dt you just found was a -5 minus dx over dt, which was -10 over 3 from A. And of course, you want to have a common denominator, so that becomes a 3, that becomes a -15, so 25 over 3 feet per second. And that is your answer. All right, you guys, let's go ahead and try a question on number 3, a linear approximation. Okay, so before we proceed forward with this question, first thing I want you guys to do is go ahead and read, whoops, that's not correct. Read the steps that's affiliated with linear approximation. All right, let's go ahead and get started with this. So it says approximate the linear y value on a graph using the tangent line equation. All right, so let's go ahead and draw a diagram with this. So here is my diagram. If I have an f of x that looks something like this, and this graph right here is my f of x, and let's say that there's a point 4 where it's going to give me a maximum. And there is obviously a slope here from this tangent line that meets that point. Okay, these are the steps. You want to identify the equation, identify the order pair near to the nearest x value, find the derivative to determine the slope, find the equation of the tangent line, and then plug the decimal value into the tangent line. So take a look at example 2. It says use linearization to approximate square root of 9.2. So I'm going to start off with the equation y equals, because of square root x. Okay. It's also I'm going to have to go ahead and take the order pair to the nearest integer. So I have 9 in there, so x equals 9. Now it says find the order pair to the nearest integer. So if x equals 9, what does y equal to? Well, y is going to be equal to the square root of 9, so y is going to be 3. Now, do I have the ordered pair? I do, because my point is be at 9, 3. Okay, done with A, B, now going on to C. For part C, it says find the equation that's tangent to this line. Or I'm sorry, find the derivative to determine the slope. Just kidding. So y prime is going to be the derivative of x to the 1/2. So that's 1/2 x to the negative 1/2, or 1/2 square root x. So then I'm going to plug in the x, so y prime equals 1/2 square root of 9, which is 1/6. So that's my slope. Find the equation of the tangent line using the point slope form. So then with that, you know that your point that's given to you is going to be 9, 3. You just found your slope, which is going to be 1/6. So let's go ahead and plug that into this equation right here. So then I'll have y minus 3 equals my slope, which is 1/6, x minus 9. Now you can go ahead and distribute this. So y equals 1/6x minus 9/6. Move the 3 over, which becomes a positive 3. Combine your common denominators. So 6, or I should find, 3 times 6 is 18. Negative 9 plus 18 is going to give you a positive 9/6. So y is equal to 1/6x plus 9/6. And then since we're talking about approximation, so now we're ready to go ahead, E, plug in the decimal value. Your decimal value is not x equals 9, it is 9.2. So y equals 1/6 times 9.2 plus 9/6. Plug that into your calculator, and you should have that this is equal to 3.033. And this is how you can apply calculus with linear approximation. All right, let's take a look at example 3. Okay, go ahead and take a look at this. We're going to go ahead and use a linear approximation to approximate the cube of square root of negative 8.1. So again, start off with identify the equation. So my equation is going to be y equals cube root of x, whatever x is. X is going to be the number closest to that. So closest number to negative 8.1 is just negative 8. So y equals the cube root of negative 8 is going to be, of course, negative 2. And then your point that's identified from this is xy, so negative 2, comma, or I'm sorry, hold on, x is negative 8. Negative 8, comma, negative 2. There we go. All right. Got the ordered pair. We're good to go. Find the derivative. Y prime, this, remember, is equal to x to the 1/3. It's going to be 1/3 x to the negative 2/3. So if I rewrite this, it'll just be 1/3. Move the exponent down to the denominator, x to the positive 2/3. And then once I have this, I need to go ahead and find the slope. To find the slope of this, I would need to plug in when x equals negative 8. So y prime of negative 8 is equal to 1/3 times negative 8 to the 2/3 power, which is then going to give me a slope of 1/12. And that's your slope. Find the equation. So your equation is going to be y minus y sub 1 over or equals m times x minus x sub 1. So y minus, remember your x is negative 8, y is negative 2. So y minus negative 2 is a y plus 2 equals your slope, which is 1/12, times x minus negative 8. So it's going to be x plus 8. Subtract the 2 on both sides. Y equals 1 over 12 x plus 8 minus 2. Now, we're now ready for the approximation because remember your original value is x equals negative 8.1. So take that negative 8.1, plug it in there for x, and you'll find that y is actually equal to negative 2.008 from your calculator. And that is your answer. All right, you guys, that's all I have for you today. If you would like, you can continue on with the rest of this worksheet. And if you need some assistance with finding the answers, take a look at the video explanation that I have right here in addition to the steps that's given to here as well. All right, have a wonderful week. I'll see you guys next time. Take care.